Take a look at this. It's a human femur, the thigh bone. Now, you might think it's just a piece of our skeleton, but really it's so much more than that. It's a record, a tiny biological hard drive holding secrets about a person's life. And today, we're going to learn how to read those secrets. So imagine this. You're a forensic investigator. A single bone is discovered at a scene, this femur, and that is all you have. It might feel like you've hit a dead end, but for an expert, this is where the story begins. The first question is always the same. What can this one bone tell us? Well, one of the very first and biggest questions you can start to answer is the biological sex of the individual. And just from this one bone, experts can be about 80% accurate. That is a massive lead from a single piece of evidence. It can be the critical first step that guides an entire investigation. So let's break down how they actually do it. Okay, so the very first step is all about what you can see. Before any high-tech tools come out, an expert just looks at the bone. They're searching for these broad, visible differences in its shape, its texture, and its overall structure. And right away, you can often feel a difference in the bone's general build. On average, a male femur just feels bigger, heavier, more rugged. A female femur, on the other hand, is typically smaller, lighter, and more gracile, which is really just a scientific way of saying it's more slender and smooth. Now let's zoom in on the femoral head. That's the ball part of your ball and socket hip joint. In males, the smooth articular surface tends to cover more than 2/3 of this sphere. In females, it's a little less. Now, it's a subtle difference for sure, but it's a surprisingly consistent clue. This next clue is really cool because it shows how our bodies are shaped by function. Just look at the angle where the neck of the femur meets the main shaft. In males, it's a wider, more open angle. But in females, it's angled a bit closer to a right angle. And there's a very clear reason for this. It's an adaptation for a wider pelvis, a key feature for childbirth. And the last part of the visual check is looking at where the muscles attached. You see all these bumps and ridges on the bone? They're anchor points for our powerful leg muscles. And because males, on average, have higher muscle mass, these attachment sites are often much larger and rougher. The bone itself literally carries a record of the muscles it had to support. But here's the thing. Just looking at a bone and saying it looks bigger can be a little subjective, right? Even for an expert. So to make this a real science, we have to go beyond just observation and start taking precise measurements. We need hard, objective numbers. And there's a scientific name for this, of course, osteometry. It's all about taking specific, standardized measurements of bones. This is how analysts turn a subjective opinion into an objective fact, something that can be measured, recorded, and compared against data from thousands of other skeletons. So, what exactly gets measured? Well, experts use these special calipers to get super precise numbers for key features, like the diameter of the femoral head or the width of the bone down at the knee. That's called the bicondylar breadth. Each one of these numbers is another piece of the puzzle, and when you put them all together, they start to build a really strong data-driven case. And get this, technology is making this even more accurate. Researchers are now feeding all these measurements into artificial intelligence programs, which can spot patterns a human eye might miss. With this kind of tech, the accuracy rate for determining sex can jump all the way up to 93.5%. It's a perfect example of how new tools are constantly making this science better. Now, it would be really easy to hear a number like 93.5% and think, okay, case closed, this is simple. But that's just not the whole story. The crucial next step is understanding the limitations, the situations where the clues might actually conflict with each other or just be unclear. You see, experts have to weigh a few key things. First, population ancestry matters a lot. The standards for a person of European descent aren't the same for someone of Asian descent, so you have to use the right reference data. Age is also critical. These sex-based traits aren't really clear in children, and the aging process itself can actually change bone structure over time. And finally, there's just natural human variation. Some women are more robust, some men are more gracile, and that creates this big area of overlap right in the middle. And this brings us to one of the most important concepts in forensic science. These skeletal traits aren't like a simple on-off switch for male or female. They exist on a continuum, a spectrum. And for any individual who falls into the middle of that spectrum, a definitive 100% certain assignment just isn't possible from the bone alone. So after all the observation, all the measurement, and all the careful consideration of the limitations, the expert puts every single piece of data together. They create what's known as a biological profile,
which is their final scientific estimation based on all the available evidence.
So, what does this all mean? It means the story that a single femur can tell is incredibly powerful, and it's backed by a ton of science. But, and this is the key takeaway, it is always a scientific estimation. It's a conclusion based on data and probability, not an absolute certainty. It's the most likely story the evidence can possibly tell us. And that leaves us with one final thought. This science gives us an amazing window into a person's life, all from a single bone. But it also reminds us that biology is rarely simple, and it's definitely not black and white. So if every skeleton really does tell a story, how do we honor the complexities of the stories that don't fit neatly into our simple boxes?